going to start looking here at 2.2. We're going to start looking at adding some rational numbers. We've done some stuff with integers in the past. And what we want to look at doing today is adding rational numbers, according to the title here. And I want to ask you guys, how can you use what you know about adding integers to add rational numbers? And we're basically going to be applying a lot of this rule stuff like we did in these examples right here to be able to do that today. So in order for us to answer this question right here, we need to understand rules of addition in order to add rational numbers. So some rules to recall. We've kind of talked about this already. Let's see if we can't make sure we understand this again. Guys, anytime you're adding two positive values right here, I'm going to pick some easy numbers. Is that okay?
Oh, yeah.
Pick some easy numbers for everybody.
Great.
How about 8 and we'll add 8 and 3. How's that sound? Obviously, what value is that? 11, right? So the rule for adding two positives, if you have two positives, just add them. It's pretty simple. Add them and keep which sign? Add and keep. Add and keep your sign then is what I'm going to put in here then, okay? And the sign we're keeping in that case is a positive, all right? So add and keep that sign. Edit, select all. All right. How about adding two negatives? Suppose I've got negative 8. Whoops. Suppose I've got negative 8 plus negative 3. What's that going to be, kiddos? Negative how much? Negative 11. Yeah, signs are the same again. So I'm going to take the 8 and the 3 and add them up. 8 and 3 and add them up. This will be a negative 11. All right? So again, same thing. You're going to add the two values together and keep your sign. Add and keep the sign. All right? And that things get a little trickier when we start talking about adding positives and negatives together. Okay? So for instance, maybe we have something like this, 8 plus a negative 3. Real quickly, what's your solution here?
Subtract.
Okay, so it's going to be a subtraction type of sign. And what was the value going to be? Not quite 11. 8 plus negative 5. Okay, be a 5. All right. Rules for adding negatives and positives here. Any single time you do this, you're going to take your bigger value, and I should say the bigger absolute value, minus the smaller absolute value. But which sign are we keeping here? Are we keeping the positive sign or the negative sign? In my solution, am I keeping the positive sign or the negative sign?
Positive.
Why do you keep the positive sign here?
Because the positive is bigger than the negative.
8's more than 3, right? Okay, so good. All right, so I'm going to write this down here. You're going to take the big number minus the small number. Which sign do you keep? The big sign or small sign?
Big.
Keep the big sign. Okay, I'm going to keep that big sign, all right? All right, then another thing we need to revisit here today to make sure that we understand what we're doing here is to be able to add fractions with an unlike denominator, all right? Be able to add fractions with unlike denominators. If I ask you this question right here, 1/5 plus 2/5, what would that be?
3/5.
3/5. If you've got 1 out of 5 plus 2 out of 5, that's a total of how many out of 5? 3/5. All right? So to make sure we add some from fractions with unlike denominators, we need to understand this right here. So as an example, I might put in here, say, what if you have something like, I don't know, 1/4 plus maybe 3/8 right here. 1/4 plus maybe 3/8 right there. First of all, in those two values or those two rational numbers that you're adding together, what are your denominators here?
4 and 8.
4 and 8, right? Are those denominators the same or are they different? Different. So my question becomes this, the 4 and the 8, can you guys think of maybe a least common multiple for 4 and 8, smallest number that 4 and 8 would divide into?
2.
Well, 2 would be a factor. 2 would be a factor. Let me give you an example. If my fractions had a denominator of 10 and 15 in here, 10 over here and a 15 over here, I would say the least common multiple is 30. Will 15 go into 30?
Yeah.
Yes.
Twice. Will 10 go into 30?
3 times.
3 times. So what's the smallest number that both 8 and 4 are going to go into?
1.
How much?
24.
24 would work.
Oh, no, 8
Not
goes
30.
16?
Oh wait,
16.
no.
16.
16 will work.
I thought you meant like factors.
16 would work. Very obvious to me you've not done that
4.
before.
No,
8.
8 would work, right?
Yeah, I got that right. So proud.
Guys, right here, 1/4. How many 8s is this?
No.
It's 2 8s, isn't it?
Sure.
If I double the top, so I'm going to say, you know, this is the same as 2 8s right here. So 1/4 rewritten as 2 8s, there's really 2 8s plus 3 8s. Are your denominators the same then?
Yes.
So we just wrote an equivalent fraction for 1/4 to match the denominator on the right. You may have to change one, you may have to change both. Sometimes they may give you the same denominator. What is 2 8s plus 3 8s going to get you then?
5
5 8s. All right, let's make sure we're paying attention, please. All right. So what I'm going to tell you over here is this. We're going to be looking for what we call sometimes a least common denominator. I'm just going to write down here, and we're going to kind of cheat this a bit today because I think it'll be easier for you. That you're going to want to find a common denominator. You're going to want to find a common denominator. All right, and that's the bottom number in the fraction. Get those bottom numbers to be the same, and we'll roll with this, okay? All right, so I have a couple of examples I want to start with here, help you out and get you going and figure out what we need to do here when we add fractions with unlike denominators. Let's roll. You guys have all this down right here?
Yeah.
Okay. Guys, example 1 says, hey, how do we add fractions with unlike denominators? The first one is a perfect example. I have 4/5 plus -3/10. First of all, guys, what's the denominator in the first fraction? 5. What's the denominator in the second fraction? 10, right? All right. 5 and 10 right here. Are those denominators the same or are they different? They're different. Okay. Now, I don't think that they're going to get too carried away with numbers on this, but the 5 and the 10, what's the smallest number that 5 and 10 would divide into equally? 10, right? Okay, if you're not sure of this right here, guys, if you're not sure of this, start listing your multiples of 5 and multiples of 10. Multiples of 5 would be 5, 10, 15, 20, and so on, right? What are your multiples of 10 going to be?
10, 20, 30, 40, 50, 60,
I'll list a few. 10, 20, 30. What's the first number that appears in both lists? 10. So the least common denominator has to be what value?
10.
So I want to rewrite these fractions as a fraction with the denominator of what value? 10. So right here in this 4/5 part right here, guys, to change 4/5 into something over 10, what do you have to multiply 5 by to get to 10? 2. So if I multiply the denominator by 2, you're going to have to multiply the numerator by 2. Okay, so Devin, help me out. What are you doing here, kid?
Come on, Dad.
What are you doing with the 4/5 part?
You're basically timesing it.
Both parts by 2, right? Okay, so what's 4/5 going to become when you do that? 8/10. So this really becomes 8/10 plus -3/10 now. Quick question here, guys. Denominator's the same now?
Yeah.
Okay, so this is really a situation where you look at your numerators. The 8 plus -3. Well, what is 8 plus -3?
5.
5. So my solution here, 5/10. Now when I get to this part right here, I always want to ask myself, is that solution in simplest form?
No.
Is that in simplest form? No, it's not. So what have you got here? 1/2. 5 is half of 10, isn't it? 5 is half of 10. So our solution right there would be 1/2. Solution would be 1/2. All right. Not a problem. Not a problem. Let's look at the next one here. Now guys, this next example right here, this next example says find 4.5 plus 17 over what? 17 over 2. Here's the deal. 17 over 2 is an improper fraction. Reason being the numerator is more than the denominator. Alright, and then secondly over here I have a mixed number, 4.5. Okay? 4.5. When you're adding fractions that involve mixed numbers like this right here, do you guys recall how to take a mixed number and turn this into an improper fraction here? We do have to switch it around, yep. We do have to switch it around, but we need to rename this 4.5. We want to make this a fraction, not a mixed number. This is a mixed number because you have a whole number out front and then a fraction right after it. You guys remember doing 2 times the
4 divided by the
4 and then add how much here?
1.
1. So here's how we do this again. To turn this 4.5, this mixed number, into an improper fraction, I'm going to do 2 times 4, which is 8 plus 1 more? 9. So 4.5 is really going to be the same as 9 over, what's your denominator here? 2. That's the same as 9 over 2. And how do I know that's right? Well, if I would pull out my calculator here, watch this real quickly. If I take the 9 divided by 2, guys, isn't 4.5 the same as 4.5?
Yes.
Alright. Well, this becomes 9 halves then plus 17 over 2. Quick question. Denominator is good to go with, or do we need to work on them?
Good to go.
Alright, they're good to go because they're the same, right, Devin?
Yes.
Excellent. Alright, so up top, what is that positive 9 plus 17? Positive 9 plus 17.
26.
26, right? So it's the same as 26 over 2. Thoughts on what that might be again? 13? How'd you get that, Maria?
Because half of 26 is 13.
Half of 26 is 13. This is really saying take 26 and divide by 2, isn't it? Simplest form then is just going to be 13 here. All right? So, adding fractions with unlike denominators in the first one. Here we had to take a mixed number and change it to an improper fraction, add them up, then divide this out. Now guys, I have a question for you. What if in the end I end up with something like this? Watch what I hit here. Say maybe 24 over 5. I don't want to leave my answer as an improper fraction, so here's what we need to do. We need to write that as a mixed number. Say you end up with 24 over 5 in the end. How many times is 5 going to go into 24? 4 times? Okay, check it out. What's 4 times 5 here, kiddos?
20.
When you subtract, what's your remainder?
4.
So when you get done doing this right here, if you ever have an answer that's left as an improper fraction, meaning the numerator is more than the denominator, you're going to want to go ahead and put that back in mixed number form. So what remainder of the 5 is left here? What remainder was left here?
4.
4. So I'm going to write this as 4 and 4.
5.
4 and 4/5. All right, 4 and 4/5. And you'll know you're right because you can always check this. Check this out. What's 5 times 4? 20 plus 4 more? 24 over 5. It's right, isn't it? Okay, so keep that in mind, all right? Keep that in mind. Okay, jump over to the second page if you would, please. All right, rational numbers can be written in some kind of a fraction form. It can be written in some kind of a fraction form. Get you a seatbelt here pretty soon. Hold your chair to come to the ground, too.
No, it's
Stay
so
there.
uncomfortable. I can't do it.
All right. Trust me, you'll get through it.
Understand, can't do it.
Adding rational numbers.
It's not ready.
Adding rational numbers right here, guys. First of all, we're going to start looking at adding decimals now at this point. And again, your rules are going to apply, but I want you to understand, when you see your problems written side by side like this, I don't like that. Anytime you have to add anything up that involves decimals right here, I want you to start working from the top down. And what do you think I'm going to tell you to line up when you start working these?
Decimals.
Line up your decimals. So I'm going to rewrite this out as negative 3.92 plus negative 6.89. All right, so Helen, you guys okay over here?
Yes.
Okay, let's, come on, get together. All right, signs the same or different here?
Same.
They're the same. So am I adding those two values, or am I taking the big number minus the small number?
Adding them.
Adding them up. So let's do that. What's the 9 plus the 2 going to be here?
11.
11, carry a 1. 1, 9, and 8, what is that?
17.
Ah, close.
30.
Average those two.
Oh, 6.
Ah,
What?
what's 1 and 9?
19. 18. I'm done. You know what?
Carry the 1.
I quit math.
Bring down what?
1 and 9 is 10, by the way, but
Thank you.
yeah. Well, I didn't know you were adding the 1 to the.
Yeah, we have to. 1, 3, and 6. What's that add up to?
The 9.
10.
No, I said.
Which sign am I keeping here? So negative 10.81. All right. Okay, so that's a pretty good start right here. I want you guys to take a couple minutes and on your own, give these 6 problems a shot right here. Give these 6 a shot right here. I'm going to go ahead and pause this. First one right here, guys. What do you have to establish?
The bottom.
The bottom. Is the bottom, are they the same? No, I can't just put them together. Okay, so if I start listing out the denominators of 4, I always start with the lower one. Start with your lower one and start listing multiples of 4. Let's see, 4, what's the next multiple? 8. Let's see, doesn't that 8 match what this denominator is already right here? So don't I have to rewrite both of them with a denominator of 8? Yeah, so it'd be negative 7 over 8. Now guys, I want this 1/4 to be something over 8. So what do you have to do to the 4 to turn it into an 8? How much would you multiply by a 2, right? So if I multiply the bottom by a 2, what do you have to multiply the top by? 2 as well. So this is really negative 7/8 plus 2/8. Okay? So there, we already know that your denominator, it's going to be an 8. It's going to be an 8. And as I look at this right here, this up top then is the negative 7 plus 2 part. What is negative 7 plus 2 going to get you?
Negative
5
3.
over.
Negative 5 over 8. Good. Okay, so that's where you'd be at. So make sure you've got that down. All right. Devin, I really like what you have up there. So I can get it on the recorder here. I'm going to go ahead and erase that and I'll put back down what you had. Devin, can you kind of explain to me though where negative 19 over 3 came from first?
Times the 6 by the 3.
So 6 times 3 is?
19.
Well, 18 plus 1 more would be 19. And now what sign do you have to put in front of it?
Negative.
Okay, so we've got to change that mixed number into an improper. So this problem really gets rewritten as negative 19 over 3 plus 20 over 3. Are my denominators, do they need work or are we good to go? They're the same, aren't they? So how about negative 19 plus 20 up top, kiddos? 1. Okay, so what is this going to look like in the end, kids? 1 over 3, 1/3. Very good. All right. Yeah.
Okay, so for mine, did I just have to get my diameters to match up?
Your denominators to match up. Yep.
Yeah.
Yep.
Whatever.
Good there. Good. Okay. In this last one over here, guys, the 2. This is a little more difficult right here because you have just a 2 out here. What I'm going to do is call this 2 over 1. All right. So look at the denominators. 1 and 2 right there. Guys, 1 and 2, what's going to be the least common denominator of 1 and 2? Ooh, careful.
2.
2, okay? You've got to change the smaller one to match the bigger one. So 2 over 1 is going to be the same as what over 2, guys? 2 over 1 will be the same as what over 2? Careful, 2 over 1 is the same. We've got to get common denominator, guys. Not 2 over 2. What did you do to the 1 to get to 2? Times 2. So times the 2 by 2. There you go. Hey, common denominators. How about 4 plus negative 7? Negative 3 over. Okay. Now, you know, you'll probably get away with negative 3 over 2, but one thing I might tell you is this. Will 2 go into 3?
No.
It won't.
It will one time.
One time. What's your remainder going to be?
1.
1. So isn't that really 1 and a half right there?
Yeah.
So I could also call this negative 1 and 1/2 here. All right. These shouldn't be too difficult right here. Stuff with decimals, I don't care if you punch it in. I just want to make sure you get it correct sign-wise, okay? Guys, here in this one right here, are the signs the same for these two or not?
No.
So take the big value and subtract the small value. Somebody want to do that for me? Go 15.3
2.5.
minus 12.5. What'd you say you got?
2.5.
Not 2.5.
I got.
You make it 2.8? Okay, should be 2.8. Run that through there again, Coach, just to make sure, okay? Am I keeping a positive sign or keeping a negative sign here? Keep that positive because 15.3 dominates 12.5. All right? Signs the same or different here, kids?
Same.
Same. So I'm going to take 8.15
Oh, it is 2.8.
and add 4.3. Okay, we can do this mentally. The 5, there's nothing over here, so just bring the 5 down. How about the column right before decimals? What's 1 and 3 going to add up to? 4. Bring my decimal down, and then how about the 8 and the 4? 12, right?
Negative 12.
And what was that again, Carlos? Negative 12.45. I agree. Okay. I'm not going to go into this last one too much, but which number is the bigger number in the last two?
0.65.
2.75, and I'm going to subtract 0.65 because my signs are different. And then which sign's going to prevail in the end? You have 2.10, which I could just call negative 2.1. All right? So we should be good with that, I think. All right? We should be good with that. You guys have down what you need right there? Let me know when you're ready, Devin. Got him?
Yeah, I got it.
Okay. All right, let's run through example 3 here. I want to get through this stuff today. All right? So everybody listen up, please. Guys, evaluating expressions. We're going to evaluate x plus 2y when x is what value here?
Negative 3.5.
Negative 3.5, and when your y value is? Now here's the deal. What we're really doing is substituting values in for x, and we're substituting values in for y. A value in for x and a value in for y. All right? What's going in for x here?
3.5.
Negative 3.5. Now, anytime you substitute something, I always encourage you guys to put parentheses around this, all right? And then this is plus 2 times, what's going in for y, guys?
1.7.
All right. So, I'll leave this as negative 3.5 over here on the left. This is really 2 times 1.7. I'll just tell you, if you would punch that up, this would be a plus 3.4. 2 times 1.7 is 3.4. All right, so the addition of those two rational values right there, negative 3.5, positive 3.4, signs the same or different there? They're different. So what's the bigger of the two values? So we're going to go 3.5 minus 3.4, which puts you where? 0.1. And then which of the two signs here would prevail again?
Why did I do that? Negative.
Negative will, right? Okay. Negative 0.1. There it is. All right? Told you this was pretty easy today, right?
Are you taking candy from a baby?
Taking candy from a baby. It depends on who the baby is. Are we cool with that?
Yeah.
Okay. All right, last page here. Just kind of an example right here, application here. In example 4, it says the table below shows the changes of a value in a stock during 1 week. Changes of a value of a stock during a week. All right, find the stock's gain or loss for the week. So on Monday, it looks like the stock gained how much here? $3.45. And then on Tuesday, what happened to the price of the stock?
Skyrocket. It went down.
It dropped down $12.90. Okay. What happened on Wednesday?
It
Drop down
raised.
5.
Negative 5.2. Went down again, right? What happened here on Thursday? Blew up, and then finally on Friday, what happened? Okay, so anywhere where you have a positive value in here, you're going to start with a net addition value, and then anytime you get to like this 1290, are you going to add it or subtract it?
Subtract.
Okay, you guys figure out the total change for the whole week right there. I want you guys to punch this stuff in accordingly. So I would start going 3.45 minus how much? Okay, you proceed all the way from Monday through Friday. See what you come up with when you punch this in, okay? We'll see if I agree with you. What are you guys coming up with? Okay, now this 5.4, is that a positive value or a negative value? It's positive value here, right? Positive value, all agree? So if that's a positive value right there, guys, is that indicating a gain in the stock for the week or a loss in the stock for the week? Okay. Now think of this monetarily. The 5.4, that's really $5.40. So what I'm going to say right here, when I add all this stuff up, we ended up with a $5.40 gain for the week. So if you had maybe like 100 shares of that stock, if that one stock and you had 100 shares of it went up that much per stock, it would be like making $540 that week. Okay? $5.40. If you had 100 shares of them, it'd be like going up $540. 100 times 540 would be $540, right? Okay, but I don't know anything about the stock market, so.
Why didn't you invest in start?
It's all good. It's all good. All right, so what I want you guys to do, we're not done yet, guys. We're not done yet. I want you guys to try these two on your own down here. Okay, I want you to try these two on your own. Guys, you remember what these bars mean right here? Remember what these bars mean? Absolute, absolute value. So in the end, you want your answer to be positive, okay? I want you guys to try those two on your own there quickly and see what you come up with. B plus 4 times A, and then A plus B, absolute value of that.
Absolute value has to be positive.
Yep. Yep. After you do the operation inside, though. Okay. While you guys are working on it, I'll just remind you, I did send out a new assignment over this stuff in 2.2. So that won't be due until Tuesday. So if you get time or if you're working on stuff, just know that 2.2 that's in your big ideas is due on Tuesday. Alright guys, hey, I want to run through this just to make sure we're cool with this in the essence of time, guys. So we've got negative 5 halves in for B. You guys agree with that? That kind of showed up weird. That's supposed to be a negative right there. If you put a positive in, that's okay. Get it fixed right up here, okay? Guys, if I take negative 5 halves, what's 4 halves, or 4 times 1 half equal? Well, if I say 4 halves, isn't that really the same as saying negative 5 over 2 plus 4 over 2 here? Would you agree with that? This says 4 times a half. So the 4 times the 1 up here would be 4. This is 4 halves. 4 halves right here. All right, so help me out. What's negative 5 plus your 4 here? Ooh, careful. Negative 5 plus 4?
Oh, that's 1 over 2.
What kind of 1?
Negative.
Negative 1 half. Very good.
That's not what I got.
Okay. Guys, again, this is a negative 5 halves right here. So what's 1 plus negative 5 since the denominators are the same? What's 1 plus negative 5?
Oh, 1 plus that's 4.
Negative 4, right? So this becomes the absolute value of negative 4 over 2.
It's negative 2.
So this is the absolute value of negative 2, but that absolute value is going to be what in the end?
2.
2. Okay, so you should have down what you need right there. I would encourage you guys, look at that 2.2 over the weekend. Come with questions at the beginning of the class on Monday. Tuesday. Due Tuesday.